Okay, welcome to Math 112, Pre-Calculus Trigonometry. Today we will be discussing radian and degree measure. Radian and degree measure. The word trigonometry means the study of angles, okay? The study of angles. And we're going to, first of all, talk about what an angle is. An angle is determined by rotating a ray, and the ray is a half line about its end point. The starting position of the ray is called the initial side. And we're going to demonstrate what this is in a couple of minutes. It's the initial side of the angle. And the position after the rotation is called the terminal side. So, what does all this mean? It says an angle is determined by rotating a ray or a half line about its end point. The starting position of the ray is the initial side of the angle, and the position after the rotation is the terminal side. So what that means is if we have some initial point, okay, and we have that half line, when we rotate this line, let's say we'll end here, then this is our initial side. When we rotate this line and we stop here, this becomes our terminal side. This end point here is also called the vertex of this angle. And we can measure from here to there will be the measure of that angle. Okay? That's the measure of that angle. And we're going to talk about how we name these angles in a few minutes. And talk about positive angles, negative angles, and all other sorts of things about angles. Let's look more at this angle. If the origin, and here we talk about the origin as it relates to the rectangular coordinate system with the x and y axes. If the origin is the vertex and the positive x-axis is the initial side, then the angle is said to be in standard position. Okay? So, if we have The rectangular coordinate system, x-axis, y-axis. If this origin here is our initial side, our vertex, and this positive x-axis is the initial side, then if we have our terminal side coming out here, this angle is said to be in standard position. Now, we can talk about negative and positive angles. Positive angles are formed by a counterclockwise rotation. So, from this initial point, or this initial side, if we rotate this line counterclockwise, then what we have is a positive angle. Okay? So this will represent a positive angle. And this is a symbol that we use for angle, the arrow. Okay? That's an abbreviation. Now, for negative angles, a negative angle is produced by a clockwise rotation. So now if I take this initial side and I rotate it clockwise, then I have an angle now that is negative. Okay? Negative angles, positive angles. Now how do we name our angles? Okay? We use Greek letters, and we will talk about some of the Greek letters. Most times they'll use the Greek letter alpha and the Greek letter beta, and we're going to show you what those look like. And they also use capital letters to indicate angles. Today, pretty much, we're going over a lot of terminology that would get us to doing actual problems. We're going to do some actual problems, but there's not going to be that many in this lecture. Coterminal angles. There's our abbreviation for angle again. Remember the arrow key. Coterminal angles. These angles have the same initial and terminal sides. For example, suppose we have this angle. Now remember, we start these angles by going from what? This positive x-axis. If we go counterclockwise, this is a positive angle. We can call this angle alpha. That's the Greek lowercase letter alpha. Okay? Now, we can make an angle that's coterminal to alpha. Okay? Because what? Coterminal angles have the same initial and terminal side. So now I can start here again from this initial side, which is the positive x-axis, and I can go in a clockwise rotation here and call this beta. This is the Greek lowercase letter for beta. So in essence, this initial side here goes to this terminal side in a counterclockwise fashion, forming our angle alpha. Here we go from this initial side, which is the positive x-axis, in a clockwise rotation to get to this angle beta. They are coterminal because they have what? You can talk back to me. They have what? The same initial and terminal sides. Coterminal angles will become very important later on, okay? They will become important because sometimes you may have to find different things about an angle, and you may have an angle that's at 500 and something degrees. But we know how many degrees are in a circle, and we're going to talk about circles next class. There are 360. So coterminal angles will become important because we can find something within that 360 range, okay? So we will need to know this idea of coterminal angles. Now, how do we measure angles? How do we measure angles? Let's look at the measure of an angle. The amount of rotation from the initial side to the terminal side. This gives us the measure of an angle. Okay? Now, there are two ways we can measure angles. More commonly, we know what? Degrees, right? We've heard of degrees. We know that there are 360 degrees in a circle. And what? How many in a triangle? 180 degrees in a triangle. You know, those are basic things that we know. So we do have the degree measure. But we have another measure, and that's called the radian measure. Okay? We have the radian measure. We're going to talk about what the radian measure is. And on your calculators, there is a radian button. You can get degrees in radians, or you can enter degrees into the calculator in radians and in the degree mode. But you have to know which mode that you're dealing with. Okay? Most times we'll use radians. We are going to look at both at the beginning. So let's look at this radian measure. One radian is the measure of a central angle theta. Theta is another one of those Greek letters. Most times they like to refer to angles as theta. Okay? That intercepts an arc S equal in length to the radius R of the circle. Now I know, we don't know what that means. You have no clue. Okay, Ms. Berger on the board, 1 radian is the measure of a central angle theta that intercepts an arc as equal in length to the radius R of the circle. We still don't know what it means, right? Let's talk about what this means when we draw this picture here. Okay? Now, we have a circle. Okay? We're going to say that this is a perfect circle. Now, we know that if this is a circle centered about the origin, okay, we know about circles that from the center of that circle to any point on the circle represents what? The radius. So let's draw a line here. This represents the radius of that circle. Okay? Now, our angle theta, this central angle theta, is formed by taking this initial side, the positive x-axis, to this line. This is our angle theta. Now, what they're saying is, also from here to there represents radius too, right? From any from the from the center of that circle to any point on that circle represents the same r, right? What they're saying is that 1 radian is the measure from this initial side to this terminal side. This length here, if this is also this arc S, if that is also equal to the length of this radius, then we can say that this angle measures 1 radian. Now let's say that again, because that was a mouthful. Let's say it again. 1 radian is the measure of a central angle theta that intercepts an arc S equal in length to the radius. So what this means, here, this origin is our center. From this origin to any point on this circle is R. So this angle theta is formed. This side is R, this side is R. In addition, if this length of this arc, which is called arc length, by the way, if this length here is also equivalent to this R and that R, then we say that this angle theta measures 1 radian. Okay? So in essence, the radius equals the arc length, then that means we have 1 radian. Is that more clear? If the radian is 1 radian if the arc length S is also the same length of our radius R. Now, let's talk about how we can get our angles, the radian measure of the angles. We know about 0 degrees, 90 degrees. How do these, come to play when we're dealing with radians? Let's see. Now, we're still dealing with this rectangular coordinate system, okay? If I draw a circle here, okay, we have this circle here and we're talking about radians, but we're still in this rectangular coordinate system. This quarter over here still represents quadrant 1, quadrant 2, quadrant 3, and quadrant 4, right? Now, let's talk about how I form these radians, okay? Let's talk about how I form these radians. Now, theta, the angle theta that we referred to over there in explaining what a radian is, theta is measured by these arc length S over the radius R. Okay? That S over R. Now, in dealing with the whole circle, the arc length, or the length all the way around that circle, we refer to as what? Circumference. And the circumference of a circle is 2 pi r, right? All over this r, which means that if we're dealing with this full circle, if we go from here, this initial side, and go all the way back to here, this terminal side, then that represents 2 pi radians. So what this means is that if I start here and go all the way around this circle and come back here, then I have 2 pi radians. That's a full revolution, okay? A full revolution. So 1 revolution of this circle gives me 2 pi radians, and we abbreviate RAD for radians. 1 revolution. How about if I do a half revolution? So here I can say that I start at 0 and I'll end at 2 pi. Okay? 0 and 2 pi here will represent the same thing. Okay? So what is half of a revolution? Is what? Pi is 2 pi over 2 or just pi radians. So what that means, if I go halfway around this circle, that's pi radians. Okay? How about 1/4 of a revolution? It's going to be my 2 pi divided by 4, which is what? Pi over 2, right? So I go what? 1/4 of the way. That represents pi over 2 radians. Okay? And how about if I do 3/4 of a revolution? Then that's what? 2 pi times 3/4, which is what? 3 pi over 2 radians. 3/4 of a revolution, 1/4, 2/4, 3/4 is here. So we start at 0, and we go to 1/4, a half, 3/4 of a revolution, and a full revolution will get us back to that 2 pi. Okay? So these are our angles. Now, in quadrant 1, we can see that theta will range from 0 to pi over 2. 0 to pi over 2. That's where those angles will lie in quadrant 1. Quadrant 2, we have angles from pi over 2 to what? To pi. So all angles within that range will come in quadrant 2. Quadrant 3, we have angles from pi to 3 pi over 2. And quadrant 4, 3 pi over 2 to 2 pi. Okay? So you can kind of pick out the angles. You can say, well, if I give you an angle, then you should be able to tell me what quadrant that angle lies in. Okay? Now, a word about these angles. If we have angles where theta ranges from 0 to pi over 2, then these are called acute angles. From 0 to pi over 2 represent acute angles. And angles ranging from pi over 2 to pi are called obtuse angles. Obtuse angles. Now let's make mention about this 0 and this 2 pi. Okay? They are at the same physical place on this picture here. But 0 represents just starting there. We have not made any, we have not gone any way around the circle. Okay, the 2 pi represents I've gone a full revolution around the circle. If you remember, we talked about coterminal angles having the same initial and terminal sides. Well, 0 radians and 2 pi radians have the same initial and terminal sides. So they are coterminal angles. They are coterminal angles. And we can find coterminal angles by either adding or subtracting 1 revolution, which is 2 pi. And we're going to look at that. Finding some coterminal angles in a little while. So let's look at an exercise. Example. We want to determine the quadrant. Suppose we are given an angle of 11 pi over 8. And we want to determine which quadrant this angle lies in. Now, let's talk about what that means. There are a couple of ways that we can determine this. 11 pi over 8. If you want to, you can get a decimal approximation, can't you? Because we know pi is on what? 3.14 and a whole bunch of numbers behind it. And we have that pi button on our calculators. So one way of doing this problem is to determine, where we are. What is 11 pi over 8? Do we know what that is? Does anybody have a calculator? Anybody have a scientific calculator? Did you come unprepared without us? He has a scientific calculator. 11 pi over 8, and I want you to check me, should be 1.375. Pi. 11 over 8. Is that 1.375? Okay. So that's 1.375 pi. Now, knowing what that is, we can probably figure out what's going on. Can we figure out what quadrant this angle's in? Well, this is pi, and this is 3 over 2 pi. 3 over 2 pi represents 1.5, doesn't it? So is that 1.375 between 1 pi and 1.5 pi? Yes. So this lies in quadrant what? 3. Quadrant 3. Okay. How about if we have just 6.02? I want to make mention. Notice that we didn't say 11 pi over 8 radians, right? We just said 11 pi over 8. Here, they're just saying 6.02. Most times when you have an angle and there is no degree symbol there, if there's nothing there, then we assume it's radians, okay? So they may say radians, and then again, they may say nothing. When they say nothing, we assume it's what? Radians. And actually, that's all we're dealing with today is radians. We haven't even gotten to the degree measure. So 6.02 radians, where is this? Well, notice I don't have a pi associated with that, do I? So pi is already in there. Well, pi is like what? 3 point something? So 2 pi is 6 point something, isn't it? 3 pi over 2 is 1.5. Okay? So I want to know 2 times that 3.14, is that greater than or less than this 6.02? Is it greater than? It's less than, isn't it? So this 6.02 is somewhere in this quadrant. 2 times pi. Calculator back there. What's 2 times pi? Let's get approximation. 6 point what? With a whole bunch of numbers. Yeah, it is. 3.14 plus 3.14. That's correct. So somewhere our 6.02 lies probably somewhere close. Somewhere here. So we're in what quadrant? Quadrant 4. How about if we had a negative angle? What do we say about negative angles at the beginning of the class? Y'all remember what we said about negative angles? They are clockwise rotations. Okay? And we want to figure out where is this 4.25. So we go clockwise. We think going from here to there, we've gone pi over 2. From here to there, we've gone pi, right? Going clockwise. So pi we know is 3.14, and we're going negatively, right? All that negative means is that instead of going counterclockwise, we're going to go what? Clockwise. So from here to there, it's pi over 2. Here to there is pi. From here to there is 3 pi over 2. So where are we? We know this is 3.14, right? What's 3 pi over 2? 1.5 times pi? I don't know what that is. Calculator, what's that back there? What? Times pi. 1.5 times pi. 4.17. It's 4 point what? 4.71 approximately. So from here to there, going negatively, this is what? Pi over 2, pi, and then 3 pi over 2, which is 4.71, which means our angle lies where? In this quadrant. Probably somewhere here is where the angle would lie. So we're in quadrant 2. So I can find out what quadrant I'm dealing in, whether it is in a negative angle, because I end up doing what? Just going clockwise, or a positive angle by going what? Clockwise, counterclockwise. Let's say that again for the cameras, okay? Positive angles go counterclockwise, negative angles go clockwise. Okay, so we can determine angles. Now, how do we get to these coterminal angles? What are coterminal angles? We said coterminal angles have the same initial and terminal sides, right? And we said that to get to coterminal angles, we can do what? Add or subtract a revolution. And a revolution is what? 2 pi. So to determine coterminal angles, we can either add 2 pi to that angle or do what? Subtract 2 pi. Okay, adding 2 pi means we'll go counterclockwise. Subtracting means we'll go what? Clockwise. So we are going to determine 2 coterminal angles. So our first angle will be 7 pi over 6. Now, I say we can add 2 pi or subtract 2 pi, but you can add a multiple of 2 pi. You can do 4 pi, 6 pi, and that'll also get you to a coterminal angle. Or you can subtract 2 pi or subtract 4 pi, any multiple of 2 pi, and that'll get you to a coterminal angle. But we'll do what's most logical. We'll add 2 pi. Now, I know we are at a level where we should know how to add this stuff without a calculator, right? Aren't we? Yes. But hey, if we're not, what do we need to do? Get a common denominator, right? 2 pi is the same as 12 pi over 6, is it not? So I can add all this stuff and get 19 pi over 6, okay? That's one coterminal angle. Another coterminal angle we can get by doing what? Subtracting 2 pi. 7 pi over 6 minus 12 pi over 6 will give me negative 5 pi over 6. Okay? So that's simple enough. Do we need to do another example with finding coterminal angles? Adding 2 pi or subtracting 2 pi? Are there questions? Yes?
What quadrant is like an axis?
The axis?
Like a wire axis?
They are called quadrant angles.
Okay.
So that means that they're not necessarily, they divide the quadrants up, so they're not in a particular angle.
So, for example, determine quadrant question, and the question was pi over 2, and the answer would be?
They probably wouldn't ask you that because that splits the quadrant. 0, pi over 2, pi, and 3 pi over 2 are called quadrant angles. It lies at a place where you really can't tell. You can't tell whether pi over 2 is in quadrant 1 or quadrant 2. So they just say, hey, you're on that. We're calling it a quadrant angle.
Is that why you put less than and not less than equal to?
Yes, yes. That is why.
They just won't ask.
They shouldn't, because you can't determine. It's stated as a quadrant angle so that splits the quadrant. And those are all special angles, and we're going to talk more about those later on. Other questions? Other questions? Okay. I don't think we're going to get through all this today, but we're going to try to get as far as we can. Complementary and supplementary angles. Have we heard of that before? Have we heard those terms? Complementary and supplementary angles. Let's talk about what that means. Two angles, or I should say two positive angles, alpha and beta, are complementary if their sum is pi over 2. Okay? Two positive angles, alpha and beta, again, are supplementary if their sum is pi. Okay? Complementary, the sum is what? Pi over 2. Supplementary, the sum is pi. Notice, we have conditions, though, to what? She whispered positive. Two positive. So these angles must be positive. So that leads us to believe that some angles may not have a supplement or a complement. Because there is a condition. Two positive angles, alpha and beta, are supplementary if their sum is pi. So we want to find, if possible, may not be possible, the complement and supplement of each angle. The first one we're going to look at is pi over 12. So, if the sum of the angles have to be pi over 2, then we can find this complement by doing what? Pi over 2 minus this pi over 12. Okay? So, pi over 2, we need a what? A common denominator of 12. So 2 times 6 is 12. So this is 6 pi, which means 5 pi over 12 is our complement. Is it our complement for real? Yes. Why? Because it is a positive angle. It is our complement because it's positive. So this is the complement. How about the supplement? The supplement is what? Pi, right? Pi minus pi over 12. Because two angles are what? Supplementary if, two positive angles are supplementary if their sum is pi. So this is the same as 12 pi over 12 minus pi over 12, which is 11 pi over 12. And that is the supplement. Okay? And we can say that it is a supplement. Why? Because it's not negative. So, had we got negative angles, we would have said what? It does not have a complement or a supplement. Okay? Okay. We use this circle here to denote angles that were in what? Radians. We're now going to do the circle again, but now we're going to talk about degrees. So let's look at degree measure. Degree measure is something that we probably can think about more so than the radians, okay? With a degree measure, 0 is still 0, okay? Okay? We know 360 degrees represents this whole circle. So a full revolution is 360 degrees. Just like a full revolution over here was what? 2 pi. So we can see 0 corresponds with 0 and 2 pi corresponds with what? 360. Now if we do a fourth of that revolution, okay, then we'll get to 90 degrees. Half we'll get to 180 degrees. And if we do 3/4 of the revolution, we'll get to 270 degrees. So 90 degrees correlates to pi over 2. 180 degrees correlates to pi. And 270 degrees correlates to 3 pi over 2. So now in degrees, these are our quadrant angles. Okay? These are our quadrant angles. Now, how do we go between the two? What if I'm given something in degrees and I want to find radians? So what if I'm given something in radians and I want to find degrees? So I need to know about conversions. How do I convert? He says with the calculator. Yeah, you can do that, but you know what? You can get messed up. You want to know how you can get messed up? Who said that? Okay. You want to know how you can get messed up? Because you may have one of those TI-83s, I know it, and all that good stuff. And, you know, sometimes you have that approximation button and stuff, and it really approximates. It really doesn't tell you what exactly it is. But if you want exact, and you know I want exact, right? Then you're going to have to learn these formulas. That was such a good question.
It wasn't really a question, man.
It was a comment. I'm glad you made that comment so I could comment. But you need to know how to do them both. Later on, once you get into doing other things, then you can use your calculator. Seriously, you can. Because now we're being, you know, at the beginning we're going to be tested on converting. Later on, conversion would just be a little small, minute part of getting to something bigger. So it won't even matter then, okay? But we need to know these conversions. So to convert degrees to radians, we're going to multiply the degrees by pi over 180 degrees radians. So whatever the degrees is, we're going to attach a pi over 180 degrees radians, simplify it, and we will have our radian measure. To convert radians to degrees, we're going to multiply radians, whatever radian measure, by 180 degrees over pi radians. Why do we use this, pi over 180 and 180 over pi? We use this because pi is 180 degrees. Pi is 180 degrees. So, let's look at some examples of conversion. The next few problems we want to write in radians. Suppose we have 315 degrees. Now, let's think logically about what happens here. Because if I'm on that test, if I have that test in front of me and I have this so-called test anxiety, I may not remember those conversion formulas, right? But I need to remember, if I remember that, hey, 180 degrees equals pi, then you should be able to figure out the rest from there. Because I want radian degrees, which means that I need to multiply this by something where my radians is in the numerator and my degree measure is in the denominator, right? Right? So I know that my 180 and my pi are there. So, hey, my degrees here would kind of like cancel out, and I have my radians. So just think about 180 degrees equals pi radians. You can put whatever in the numerator and the denominator so that you can cancel the degrees or the radians out and have what you're looking for. So here we're looking for radians. So I know I have this degree measure in the numerator. Well, I need a degree measure in the denominator to cancel the degrees out and be left with radians. So what I have is 315 pi over 180. Now, do I want to leave my answer like that? No. Why? Because it's not in simplest form. So I need to simplify this fraction, however you want to simplify it, to get 7 pi over 4. Okay? And we don't have to put radians. We can say radians, but we know that when we don't see anything there, it's assumed to be radians. Most times, they will not use the word radian. But in conversion, we might need to do that. How about if I have 120 degrees? So I know I want my degrees down here and my radians here. So I have my 180 and my pi. Right? So I have 120 pi over 180. And I should be able to simplify that one very easily. 2 pi over 3.
So you prefer to leave them like that than to multiply it out? Like multiply 7 by pi and divide it by 4?
Yes, I would prefer that you leave the pi in there. You want to know why? Right. This is an exact measure. Remember, pi is just an approximation. So you would end up getting approximate, and we want exact values. So leave the pi in there. Okay. How about if we want to write in degrees? Well, I don't think I did any. Well, let me make up something. Suppose we have, let's say, 3 pi over 4. My examples in my notes, I didn't do any degrees. I did them all that way. But, hey, we can go with it. Suppose we have 3 pi over 4 radians. How are we going to convert this to degrees? We know we want the degree portion where? In the numerator. And the radian portion where? In the denominator. So my pi's cancel. My radians cancel. So what I have is 3. This is degrees. Okay, where's my calculator person? Here we go. 3 times 180 is what? Does 540 go into, does 4 go into 540? No. We got to simplify this. 2 goes here what? So it should go in there, shouldn't it? So 2 goes here what? 135 degrees. Okay? See, I don't have a calculator. I guess I could have brought mine. But we have to do these things. And if you can't break it down, like I didn't see that 4 went to 540, start with 2 and keep on going. Okay? So this is how we go from radians to degrees. From radians to degrees. Now, you can determine what quadrant. And I'm not going to go through with this. But with degrees, it's very easy to determine what quadrant angle is in, right? Because we actually, you won't have to figure out what that pi is, but we know that when we have a negative angle, we go which way? Clockwise, okay? Coterminal angles are the same. Remember when we had coterminal angles and dealing with radians, we added or subtracted what? 2 pi, which means we're going to add or subtract what to get coterminal angles here? What's equivalent to 2 pi? 360, right? So, it just follows on. Coterminal angles, we can add or subtract 360 degrees. We talked about complementary and supplementary angles. Complementary angles, the sum had to be what? Pi over 2. So what must the sum be here? 90. Supplementary angles, positive angles now, remember? 2 positive angles are supplementary if their sum was what? Pi, but now 180. Okay? So things are just converting along.